In this lecture, we are going to discuss about the convergence of a sequence in a metric space. If a convergent sequence in a metric space X has infinitely many distinct point then the limit limit of the sequence limit of the sequence is the limit point of the set of points of the sequence. In a statement, a convergent sequence in a matrix space is given. It has infinitely many distinct points. If it has infinitely many distinct points, then limit of this sequence become the limit point of the set of point of the sequence. That is, limit of the sequence become the limit point of the range set of the sequence. Okay. Proof. Right. Let X be a matrix space and Xn be a convergent sequence one Xn be a convergent sequence with limit with limit x. We shall assume assume that x is not limit point of the set of point of the sequence. That is, x is not a limit point of the range. Okay, that is, we shall show that action contain finitely many distinct points. Okay, if it is a finite set, then it does not have limit point. So we shall show that action has finitely many finitely many distinct finitely many distinct many distinct 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 finitely many distinct. Since x is not limit point limit point of of the set of point of sequence, limit point of a, the set of point of the sequence. So for epsilon greater than 0, we will always get an open sphere center at x, radius epsilon. If we take intersection with this set A, it is M. Okay, as x S epsilon xn converges to this open sphere center at x radius epsilon for all n greater than equal to n1. That is, after a certain n greater than n0, all the xn belongs to this open sphere center at x radius epsilon. Here we have, from the definition of limit point, we have got there is no point between a and the open sphere s epsilon x, and here we have got after a certain n greater than n naught, our all xn belongs to x. That means after certain n greater than n naught, our xn are equal to x. Okay, that means after certain n greater than n naught, all xn will be equal to my x. Okay, that, that means for all n greater than n naught. That means after n greater than n naught, if this is after n greater than equal to n naught. If this is my n naught position, in this position n less than n naught, we have only finitely many distinct points of action. So this action has finitely many finitely many distinct points. Okay, finitely many distinct finitely many distinct points. This is a contradiction. This is a contradiction and this contradiction, because if the convergence sequence contains infinitely many distinct points, then its limit becomes limit point of the range set. Here we are getting a convergence sequence if limit point of the range set is not equal to the limit of the sequence, then we will get a sequence with finitely many distinct points. Hence the proof. Okay, hence the proof. This contradiction arises because we have considered x is not limit point of k. That means x is our limit point of k. That means a convergence sequence has a limit if it has infinitely many distinct points, then its limits and limit point of the set of point of the sequence are same. That is, limit of the sequence and the limit point of the range set are equal. Okay, with that I would like to conclude. Remaining will be in the next